Today I'm repairing a Leak Stereo 30 Plus. It's for a customer. It's been popping fuses apparently. Both AC and DC fuses. The AC fuse blew. The owner replaced it and it of course promptly blew again. We're going to repair it and make sure it's not going to happen again. Now looking at the schematic, it's quite likely that the culprit will be either these four diodes that make up the bridge rectifier in the power supply, which are these four on the schematic and these four laced across the mains transformer and the amp itself, or alternatively it could be this first filter cap C6 on the schematic, which is a big silver can close to the mains transformer in the amp. That's this one. Or of course a short circuit around the pilot lamp, so I've disconnected that for now to take it out of the calculation temporarily. Now the reason I say that of course is that they're all this side of the DC fuse, which was not popping. So I checked this big cap, it was high, 2800 plus microfarads, and its ESI was a bit high, so needed to replace, but not the culprit. These diodes, however, were not okay. Two had just opened the gates and let the whole fucking party in. So I replaced all four, insulating the leads properly to avoid dangerous shorts and all the rest of it. Now to replace this big filter cap, you'll have to install a tag strip to mount the new capacitor on, because it'll be a fifth of the size. Make sure the ground connection there is very tight. Obviously, as always, also be very sure of the polarity of the cap before soldering it in there. Now I'm using two to make up the capacitance, as it's lockdown 2020 at the minute, so I couldn't get a new one of exactly the right value. Now remember, if you do this, both caps have to be rated to take the whole voltage. That's because they've each got the full voltage at the positive terminal, you know. So remove this DC fuse and then we can check the power supply isolated. First with the pilot lamp still disconnected, and we'll expect 36 volts of AC and 48 volts of DC at the top of that cap. So monitoring them both at once, you have the 2 meters where you can read them together, and one set to AC volts across the main secondary and across the filter cap, as so, one set to DC volts, and you switch the amp on but without the mains applied to start with. Then you switch it on at the power supply, and then you're not reaching over the amp with the mains applied, especially if you need to cut the power quickly. Once you've done so, you bring up the voltage on a variac if you've got one, slowly of course, pausing along the way to check that everything seems normal. And of course, bearing in mind that with no load on the power supply, it's likely that 36 volts of AC will probably create a little more than 48 volts of DC, which is entirely normal with that DC fuse removed. Also bear in mind that the line voltage in your house will not match the transformer primary perfectly, so your variac with its own losses acknowledged too will have a seemingly inaccurate reading. Again, no worries. What we're testing here is simply the mathematical ratios across the supply and its stability and its ability not to set on fire, you know. And as predicted, variac at 240, and we're not yet at 36 volts AC, so I'll just nudge it up a tad and everything's fine. Then repeat this with a pilot lamp reinstalled, of course, to make sure that everything behaves in the same way. Then the next thing that you need to do is keeping your DC voltmeter across the filter cap to monitor it. Discharge the cap through a high power wire resistor to ground. I strap mine into an older test screwdriver soldered in at the tip and to a wire at the back, so I can do it easier. That's not quite as important as in a tube circuit, obviously, you know, But it is the difference between killing yourself and burning half your hand off, so it's still worth doing. And that'll do for now. Now, knowing that this amp was built around, well, 50 years ago, we have to check the electrolytic caps throughout, but it's not a complete renovation job, so we'll just be replacing the suspect ones. To start with, the other main filter caps, which on the schematic are here, C2, C3, C4, and then in the amp, this one up by the headphone outputs, and these two in the back corner next to where the old silver can was. And you'll notice with these two is a cluster of resistors that, because of the physical changes we need to do, will have to be repositioned along with the new smaller caps. And of course, unless they read perfect, I'll just replace them with new ones. So that's these three resistors on the schematic, R1, R2, R3. In terms of wattage, I'd say despite the size, they're probably only actually 1 watt resistors, but I'm going to replace them with 2 watt just to be sure. And while we're making the physical changes necessary up here, it's a good idea to check these two capacitors that block DC from the headphones. On the schematic, it's this one and its equivalent on the other channel. I found that they were high, and as they protect your ears from a popped headphone driver, I think we'll replace them. Right, it's a good idea to remove the 4 boards for easier access. Be careful doing that, obviously. First, an extra little tag strip to accommodate that first filter cap that was by itself at the front of the chassis. And luckily the 2 new caps in the headphone circuit fit securely in the old retainer from one of the originals. All these contacts are on really rigid stalks. They won't move, and if they do, they're of such a length that they won't touch anything else. And the other 2 filter caps, again, fit snugly in an old retainer. Again, make sure everything's rigid and secure, and any contacts that are exposed are of such a length that they can't touch anything else, even if they should move. So to recap, excusing the pun, we now have all these capacitors replaced, and of course all the diodes in the power supply, and we've got the 4 boards out for inspection, ready to work out what we need to do next. Now the first thing I notice is the exposed tails on these resistors. The fact that the resistors are tarnished and crumbly looking, meaning they've been too hot. And also these resistors are 0.5 ohms but with a 20% tolerance. And on a tiny value like that in a critical part of the circuit, kind of crappy practice, to be honest. So I opted to upgrade them somewhat to some with a higher wattage rating and a 1% tolerance, checking of course that they were going to fit comfortably within the space and that the leads were going to fit through the holes in the board, etc. I'm going through the caps in this board. I found these 2 to be a bit out of whack, so we'll replace those 2 while the boards are out. On the schematic, they're here, C29, C32. And here we go, 2 new resistors stood off the board, leads insulated. They'll almost certainly outlive the amp. Capacitors changed, no need to insulate these, of course, the way they're set is fine. Of course, bear in mind all the new bits must fit in the space the old ones did, or the cars won't go back in. So do the other board, then clean up the backs, and we're almost done. So we need to clean up the flux from the joints we just did, and also the grubby contacts that haven't been seen in 50 years or so. Best thing is to put some isopropyl into a little container and use a little wire brush to gently clean up with it. Next is to clean out all the old gunk from around the chassis. Pick the big bits out with tweezers, then dip a cotton bud in the alcohol, the isopropyl, and gently wipe around, collect up all the remaining dust. Then use an isopropyl spray to clean out the board sockets, posts, switches, pots, and then we can safely reassemble it. And there we are, all spick and span, as they say. Everything cleaned, wiring checked, ready to be reassembled, boards wise. Now the preamp board's checked out fine, and as mentioned at the start, this not being a full renovation, I've left them as they are, and the amp is now back together. And a quick check of critical voltages, and then a functionality check, and it's back to the happy customer for many years of pristine listening pleasure. Again, make sure all these contacts are never going to touch each other. Everything's nice and neat, secure, and check all your wiring before you try to plug it in again. Unfortunately, these photos and clips were only meant for record in case the customer wanted to see the work that was done. This is my first video of this kind, and I didn't know I was doing it until after I'd returned the amp to the customer, which means I have no clip of the sound test, as obviously the customer didn't need that. He was going to hear it when he got home, right? So I'll correct that mistake in future videos. Please feel free to suggest how I could improve these videos, as the whole point is to pass knowledge on and hopefully contribute to a more DIY music scene. Thanks for watching.